Okay, imagine this. You pull open your curtains one morning, maybe at dawn, and bam, not one, but two suns. Right there, side by side, blazing in the sky.
Wow.
Yeah, and the ground, it's glowing with these double shadows everywhere. The sky is just drenched in colors you've never even conceived of.
It sounds like pure science fiction, right? Straight
Yeah,
out of Star Wars.
exactly.
Yeah.
But here's the thing, it isn't just a fantasy, it's a real astronomical possibility, and that's what we're diving into today.
Hmm.
We're tackling that big question. What if Earth, our Earth, orbited two suns, like Tatooine? What would it actually look like? Could life even, exist?
And what kind of civilizations might pop up under skies like that? It's fascinating.
It really is.
So we'll dig into the material you've gathered, look at the huge implications, everything from light and shadow itself to climate, gravity,
Yeah.
even like human psychology and culture.
And we'll show you how surprisingly common these systems actually are out there.
Right. It's a thought experiment, sure, but one that's firmly grounded in what we know about the universe.
Okay, let's unpack that first bit. The idea of two suns, it feels so alien to us, right, with our one familiar sun.
It does.
But the research, the sources we looked at, they suggest our sun is actually, well, kind of the odd one out.
Yeah, it's actually pretty surprising for most people to hear. But most stars in the galaxy, like well over half of them, they're in binary or even multiple star systems.
Over half, really?
Our single sun is, statistically speaking, a bit unusual. Some of these star pairs orbit super close,
Yeah.
whipping around each other in days.
Wow.
Others are really far apart, separated by light years. And the really cool part, we know for a fact that many of these systems have planets.
Planets orbiting both stars?
Exactly. We call them circumnary worlds.
Oh.
They orbit both stars at once, so real-life Tatooines. They're definitely out there.
So it's not just theory. Astronomers have actually spotted these.
Oh, absolutely. The Kepler telescope gave us some amazing proof. Kepler 16b is the famous one.
Yeah, I remember reading about that one.
Yeah, it's a gas giant about the size of Saturn, and it definitively orbits two stars. No question.
So that really confirmed it.
It did. It showed these systems can host planets, which means, Earth could have formed in a system like that. It wasn't impossible.
It just comes down to cosmic chance, really.
Pretty much. It makes our single sun feel a bit
Yeah.
different, knowing that.
Okay, so stepping away from just the existence of these systems, let's talk about the view. Imagine the sky. What would life actually look like?
Ah, yeah, the visual spectacle. It's mind-bending.
The sources paint this incredible picture.
They do. I mean, think about the most basic thing, shadows. Every single thing, a tree, a mountain, you would cast two shadows.
Two shadows. That's hard to wrap your head around.
And they wouldn't just sit there. They'd constantly be shifting, merging, overlapping, twisting as the two suns moved across the sky.
It'd be like a constant moving artwork on the ground.
Totally. And sunrises, sunsets. Forget about it. You might have one sun blazing gold, the other maybe a cooler white, or even red. The sky would just explode with colors we've never seen.
Daily masterpieces.
Absolutely. And sometimes the suns might even eclipse each other, right? Dimming the world unexpectedly.
So light levels wouldn't even be constant during the day.
Not necessarily. And the whole rhythm of light and dark would be transformed. Some days, maybe both suns rise close together, just flooding the world with this intense light.
Brighter than anything we know.
Way brighter. Other times, one sun might set while the other one just lingers, hanging in the sky, creating these really long, strange twilights, half-nights almost.
So night, as we know it, true darkness, that could be rare.
Extremely rare. Depending on the orbits, you might go weeks, maybe even months, without proper darkness.
Wow. That would mess with your head.
Wouldn't it? Think about the psychological impact. Languages would probably need totally new words for things like double dawn or that lingering light period.
Yeah, our vocabulary is so tied to one sun.
And culture. Myths, religions, they'd all be built around these two celestial beings. Are they brothers, rivals, lovers, protectors? So different from our single sun stories, darkness itself might become like a sacred, precious thing.
Okay, so visually stunning, psychologically profound. But what about the physical reality? The climate, the environment? Two suns must mean problems.
Yeah, big problems.
Yeah.
The sources are pretty clear on this. Two suns equals way more energy hitting the planet.
Assuming they're like our sun.
Right, if you had two sun-like stars, Earth would basically cook.
So runaway greenhouse effect?
Pretty much. Think deserts spreading everywhere, oceans boiling away, shrinking. Polar ice completely gone, sea levels rising catastrophically.
Mm.
Just a sweltering, harsh world.
And weather. More energy usually means wilder weather.
Oh, exactly. The winds, the storms,
Yeah.
they'd be fueled by all that extra energy, plus the complex gravity. They'd likely be far stronger and much more unpredictable than ours.
Okay, what about seasons? We get seasons because of Earth's tilt.
Right? Our tilt relative to our single sun. But with two suns, it's a whole different ballgame. The research suggests it depends heavily on how the stars are arranged.
Close together versus far apart.
Yeah. You could end up with wildly exaggerated seasons. Or maybe none at all. Just constant conditions.
Or maybe summers that last for years. Or sudden ice ages.
It's all possible. You could get these incredibly long, brutal heat waves or plunge into ice ages relatively quickly, depending on the orbital dance. It messes with the stability we take for granted.
And you mentioned the lack of night. That's got to be a huge factor, too.
Oh, absolutely critical. Night isn't just downtime for us. It's when the planet cools off, ecosystems restore themselves, our sleep cycles, biological clocks. They depend on that dark period.
So take that away or make it rare.
And the whole planet becomes a harsher, more stressed environment. It impacts everything, right down to how plants photosynthesize, how animals behave.
So heat, light, chaotic weather.
Yeah.
But the sources seem to suggest the real danger, the ultimate threat, wasn't the light, but the gravity.
That's a key point. Yes, light and heat are huge challenges, but orbital stability, that's the make or break factor.
How so?
Well, the delicate gravitational dance is everything. If the two stars are pretty close to each other, Earth could actually find a stable path orbiting both of them.
Like orbiting their combined center of gravity.
Exactly. That's
Yep.
what we call a circumvenary orbit. It can be stable,
Right.
predictable even.
Okay, so that's the safe scenario, relatively speaking.
Relatively, yes.
Yeah.
The real danger comes if the stars are far apart. Then Earth is caught in this gravitational tug of war.
Pull this way and that way.
Precisely. And its path can become unstable, chaotic even, a wobble.
And that wobble, what does it do?
Well, best case, it could cause those wild swings in climate we talked about, devastating for life trying to evolve.
And worst case.
Worst case, Earth gets ejected, just flung out of the system entirely.
Kicked out into deep space.
One wrong tug, one gravitational nudge too many from that second sun, and yup, our world could be sent spinning off into the frozen darkness between the stars. Game over.
Wow, that's terrifying.
It really highlights how incredibly fine-tuned our own situation is. The stability of our entire planet, life itself, hangs on this precise cosmic choreography.
We really lucked out with our single stable star.
We really, really did. It puts things in perspective.
But, okay, let's assume a somewhat stable orbit exists. Life is incredibly resilient, isn't it? The sources talked about adaptation.
Oh, absolutely. Evolution is ingenious. Life would find ways.
So what kind of adaptations could we imagine? For plants, maybe.
Well, plants might need to handle way more light, more radiation, so maybe they evolve super efficient photosynthesis or develop leaves that are reflective like mirrors.
Or filters built right in.
Yeah, natural filters to block the harmful stuff for animals.
Well, dealing with that glare would be tough. Maybe things evolved double eyelids.
Double eyelids, how would that work?
Like one set, maybe translucent to cut the glare, like built-in sunglasses.
Yeah.
And another set underneath for clearer vision when needed.
Huh, clever. Some ecosystems might struggle, of course. Coral reefs, needing specific light, they might bleach out. But maybe deep sea life, shielded from the worst of it, could really thrive.
Okay, and what about us? If humans evolved there, or maybe arrived later, how would we adapt?
Physically, maybe lighter skin becomes even more advantageous for reflecting radiation. But the bigger changes might be behavioral or internal.
Like our sleep.
Exactly. Our circadian rhythms are so tied to a 24-hour light-dark cycle. Without consistent night, we might evolve to sleep more like cats do.
Oh.
Polyphasic sleep.
Napping in short bursts throughout the day?
Could be. Just grabbing sleep whenever the light conditions allow or when the body demands it. And here's a really profound thought from the sources.
Yeah.
Dreams. As we know them, those vivid narratives in deep, dark sleep. If true darkness is incredibly rare, maybe dreaming itself fades from human experience.
Whoa. No dreams.
It's possible. They could become like a forgotten artifact of biology. Imagine how that changes culture, psychology, our whole concept of the subconscious.
That's huge. It really shows how much our sky shapes us, inside and out.
Fundamentally, from our skin to our sleep to potentially even our dreams. Our celestial environment dictates so much.
So adapting is one thing. But how does a civilization get started? How do you build cities, develop technology under constant, intense light and maybe chaotic climate.
Adversity breeds invention, right?
Right.
The sources suggest survival would demand incredible ingenuity.
Like what kind of tech?
Well, you'd need amazing cooling systems, obviously. Maybe vast underground cities become the norm, just to escape the surface conditions.
Sheltering from the glare.
And maybe massive adjustable reflective shields. Huge structures designed to manage the sunlight hitting entire regions.
And energy.
Oh, energy would be the one thing you have in abundance. Solar power would be almost limitless. That could actually accelerate technological growth by centuries. Imagine civilizations running on these incredibly powerful twin solar engines.
But there's a weird paradox mentioned about space.
Ah, right. The night sky. If the sky is constantly bright, maybe washed out by two suns,
Mhm.
do you ever see the stars?
Good point.
If you don't see the stars, does astronomy even get started?
Mhm.
Our entire understanding of the cosmos began by mapping those points of light.
Yeah.
Take them away. Maybe you stay planet-bound for much longer.
Or does the constant presence of these two huge dynamic suns make you more curious about what's out there, pushing you to space sooner to figure them out?
That's the paradox.
Oh.
It could go either way. Does the challenge stifle you, or does it push you harder?
And culturally, what does it do to art, religion, philosophy?
The sources suggest a cultural explosion. Imagine festivals centered around those rare, precious eclipses or the fleeting moments of true night. That would be a huge deal.
Night becomes sacred.
Totally. Religions would almost certainly focus on dual gods, fire and light, maybe creation and destruction, constantly interacting in the sky. Painters trying to capture those insane sunsets, philosophers debating the relationship between the two suns. It would dominate everything.
It really poses that question. Does hardship crush culture? Or does it ignite something even more vibrant?
And the evidence, or at least the thought experiment, leans towards ignition. A surge of creativity fueled by the unique environment.
And the amazing thing is, as we said, this isn't just a thought experiment anymore.
No, it's real astrophysics now. We're finding these planets.
We mentioned Kepler 16b. Are there others? Systems with multiple planets even.
Yep. Kepler-47 is a great example. It's a binary star system, and we know it has multiple planets orbiting both stars.
Multiple planets in a stable orbit around two suns.
That's right. Now, many of the ones we've found so far are gas giants, because they're easier to detect. But there's no reason smaller, rocky worlds couldn't exist there too. We just need better tools to find them.
And for any life on those worlds, that's normal.
Exactly. Two suns, double shadows, weird twilights. That's just home for them. They might look at our system with its lonely single star and think we live in a strange, maybe even desolate place.
That's our normal in perspective, doesn't it?
Completely.
And thinking about the future, maybe one day humans do colonize planets like that. We'd face incredible challenges, sure, but imagine those skies, inheriting that abundant energy.
It's a sci-fi staple, but grounded in possibility now.
Try to picture it. A city on a two-sun world. You wake up to blinding double dawns, kids are playing, casting those twin shadows, farmers working under constant light, maybe with advanced irrigation because it never cools down much.
Homes built differently too. Thick walls, maybe partially underground, lots of shaded areas.
And maybe when that rare, true night finally falls, everything stops. People gather, tell stories, look up in absolute wonder at the darkness.
A holy time, perhaps. What's crucial here, I think, from all these discoveries and these thought experiments is what they teach us about our own home.
How so?
They're just powerful reminders, aren't they, of how fragile our own orbit really is, how incredibly rare and lucky our stable, comfortable conditions are. It forces us to appreciate the delicate balance here.
So we've taken this journey, imagined this world of double shadows, crazy sunsets, the whole cosmic dance, explored how life, culture, tech might adapt. What's the big takeaway for us living here under our single, reliable sun?
I think it really underscores how precious and perhaps unusual our situation is. Orbiting one stable star gave us this relatively gentle environment, a two-sun world, likely much harsher.
But also,
It highlights that incredible resilience, human creativity, life's ability to adapt when faced with enormous challenges. It's kind of inspiring in a way.
it is.
And maybe civilizations on actual Tatooine-like planets out there, maybe they look up at their twin suns with the same sense of awe that we feel looking at our sky.
A different kind of awe, but awe nonetheless.
Exactly. And thinking about their awe, their adaptations,
Right.
what could that teach us about perspective? About the sheer mind-boggling possibilities for life across the universe? Just widens the imagination, doesn't it?